So in this video I'm going to prove from first principles that the derivative of arccot x with respect to x is minus 1 over 1 plus x squared. So we know from first principles that the derivative of arccot x is the limit as delta x approaches 0 of arccot of x plus delta x minus arccot of x all over delta x. Now we know that a, or we can let a equal arccot of x plus delta x, and b equal arccot of x, which means cot of a equals x plus delta x, and cot of b equals x. And this also tells us that delta x equals cot of a minus cot of b. So we know that as delta x approaches 0, then a will approach arccot of x, which is just b. So a will approach b, which is the same as saying a minus b will approach 0. And so we can change this limit to the limit as a minus b approaches 0 of a minus b over cot of a minus cot of b. Now we know cot of x is just 1 over tan of x, so this is the limit as a minus b approaches 0 of a minus b over 1 over tan of a minus 1 over tan of b. Now if we combine these two fractions, we get the limit as a minus b approaches 0 of a minus b over tan b minus tan a over tan a tan b. So this is the same as the limit as a minus b approaches 0 of a minus b over. Now I proved in a separate video an identity for tan b minus tan a, and that is sine b minus a over over cos a cos b multiplied by 1 over tan a tan b. Now from here we see that this is the same as the limit as a minus b approaches 0 of, now because this is the denominator of a denominator, we can just flip this to the numerator, becoming cos a cos b tan a tan b over sine of b minus a over a minus b, because this a minus b could just be flipped and put on the numerator and it would be the same. Now here we see this is the same as the limit as a minus b approaches 0 of cos a cos b. Now tan a tan b is just the same as sine a sine b over cos a cos b. So we multiply by sine a over cos b, sine a over cos a, multiplied by sine b over cos b, over, now this is going to become minus sine of a minus b over a minus b. And we see that this is just the same as this denominator here if we times the inner function of the sine function by -1. And now I proved in a separate video that the limit as h approaches 0 of sine h over h equals 1. And so we see here, this is that same limit where we have h equals a minus b. And so this will become a 1. So this is the limit as a minus b approaches 0 of, we'll take our negative to the numerator. Now this cos a will cancel this cos a, this cos b will cancel this cos b, leaving us with minus sine a sine b. And we know that as a minus b approaches 0, a approaches b. So this is just going to become minus sine b, which is minus sine squared b. So earlier we said that cot of b equals x, which means that cot squared b equals x squared. So 1 plus cot squared b equals 1 plus x squared. And this is the same as cosec squared b. And so 1 over 1 plus x squared equals 1 over cosec squared b, which equals sine squared b. And so if we just take the negative of this, it will be the same as this. And so our final answer is minus 1 over 1 plus x squared. And so we proved it. That's all for this video. Thanks for watching. If you have any questions or video suggestions, leave them in the comments below. And if you want to see more content like this, subscribe now.